Hi guys, I'm going to try and make this tutorial nice and quick for your snow day. These are the notes that we took in class on Monday. If you were absent, you should screenshot these and grab them for yourself. So we went over the differences between the real atom and the Bohr model of the atom, which is the model we're going to use in class, kind of the way you use maps in world cultures. And we talked about what the word nucleus means. It actually is a little Greek word that means little nut, and it kind of means center. And you can have two different kinds of centers. We talked about the fact that you can have a center that's actually physically in the middle of something, or you can have a center that's more of a metaphor for a place where something important happens. So in the cell, it's kind of a metaphorical center. It's the center of control, the nucleus, for the operations of a cell. And in the atom, the nucleus is the real center. Then we just reviewed how charges can repel or attract each other, depending on whether or not they're like or opposite from one another. And then in most of my classes, we filled out a little chart about the particles that make up an atom. So if you were in one of the classes that didn't quite get to fill out that chart on the top, you can grab that right now. We already discussed all these things, but we didn't really fill out the chart in one of my classes. I think it was period 2. We talked about the atomic mass unit, AMU, and we talked about the fact that protons are positively charged, neutrons have no charge, electrons are negatively charged. We talked about where these different particles can be found. Proton and neutron are found in the nucleus, but the electron is found in the electron cloud, and that's really what this tutorial is going to be about, the electron cloud. And we also said that the electron has virtually no mass, almost no mass, so we don't count it as having any mass when we're sort of building atoms and drawing Bohr models. But they do have some mass. It's just really, really, really tiny. So this is where the notes get new. So you're going to be paying a little more attention here if you're only watching for the new stuff. Okay, so down here, I have a different version of the Bohr model, slightly different than the one we did in class. You can see that these electrons are not all paired up, and that you'll see that sometimes. We pair the electrons up because we're going to be doing something called bonding. And when you're bonding, it's important to have your electrons arranged just so, but you'll often see pictures of the Bohr model looking like this one that I just pointed to there. But what I really want to get at is in the real atom, the quantum model of the atom, the electrons do not follow little pathways like planets. They don't orbit. They exist in what are called probability clouds, and I define that down at the bottom, so I'm going to have to move my screen up. Let me erase all my little writing so it doesn't look weird. So write this definition in on your little sheet or take a screenshot, whatever you prefer. Probability clouds are areas where a pair of electrons, that should say are most likely to be found based on their energy. So probability clouds are areas where a pair of electrons are most likely to be found based on their energy. Can it be called a typo if you handwrote something? Sorry about that. This is why you should revise and edit your work, children. Okay, so electrons are most likely to be found based on their energy. All right, so what does that mean? Well, I'm going to give you a really kind of ridiculous example using my house, my husband, and my dog. Okay, I stole this image from SimCity, which is a really awesome game. I just Googled it and grabbed this image. So we're going to pretend that this is the town where I live and that the starred blue house is my house, because I love blue. So I'm going to live in this imaginary blue house with my husband and my beagle. So what I want to do is make a probability cloud for where my husband might be on any given day from the house. And he works there, so he's at the house quite a bit. But there's other things in the neighborhood that are going to affect where my husband goes. So I'm going to star them also in white. So we've got, this is the house right here, where the little white sign is. And then over here, this is the park where he likes to walk the dog. And over here, in this crazy looking orange house, is a very mean dog that lives over there that my dog is kind of afraid of. So what we're going to do is we're going to create, oh, I almost forgot, very important, all the way down here, this is the burger place that my husband really likes. So these are the locations where my husband is likely to wind up or stay away from, right? And what we're going to do is I'm going to, for the next year, I'm going to put a little device, tracking device on his phone, and I'm going to track where he is at noon every single day for a whole year. And then we're going to collect all that data and create a map. So I'm just going to simulate that map being created over a year's time. I'm not going to do 365 dots, but I'm going to give you an idea. So let's say I do it on the first day, and not surprisingly, there he is. He's a little pink dot in the house. And then, you know, most of the days he's somewhere in the house, but occasionally he's out here because he's starting to walk the dog, and he's in the house, and he's walking the dog. He's on his way to the park. He's walking the dog. He's walking the dog. He's scared of the big dog. He's hiding behind the yellow house, going straight for the park. They're at the park. They're hanging out at the park. Ooh, let's go over here and have some burgers. Having burgers, having burgers. Lots of burgers. So as you can see, over time, you start to get a picture that kind of looks like a cloud. Do I know exactly where my husband is on any given day? No. But I could draw a sort of shape around the places he's likely to be. And that shape would be really weird shaped. That bizarre looking shape is my husband's probability cloud. He could go anywhere in the neighborhood. He doesn't have to stay in that probability cloud. I'm sure there will be days when he'll be like over here visiting the neighbor. Oh, what's up with that little pool you've got there, neighbor? Or, you know, maybe he goes, you know, totally off the map 1 or 2 days. He flies to Chicago to visit his mom or something. I don't know why he would do that because his mom doesn't live in Chicago, but you know, you get the idea. So this is a map not of where he is, but of where he's likely to be. And I could use this then the next time, you know, let's say 2 or 3 years from now, I decide, you know, I wonder where Kevin is, you know, that's my husband's first name. And I could say, well, I guess I'll go look at the probability map and figure out he's got to be somewhere in that weird shaped thing. And that's where I would go looking for him if I wanted to find him. Seems like a little extreme for an actual person with a cell phone because I could just call him. But you can't call electrons. So probability clouds for electrons show you where they're likely to be. Now, I want you to think about this. What made this shape this way? Well, there were 2 things. There are places my husband is attracted to. So he's attracted to the house where he works. He's attracted to the park where the dog likes to play. And he's attracted to the burger joint. And there are places he's repelled by. Our dog does not like this dog, so our dog stays away from this area. And that's kind of what makes up the map of where my husband is likely to go. Same thing for electrons, but electrons are much simpler than my husband. Electrons are attracted to the nucleus, and they're repelled by other electrons. So this is what limits their motion. Also, they have one other thing that affects them, and it also affects my husband, but I didn't include it in this map: their energy. How much energy they have is going to determine where they go as well. You can imagine that there's 2 maps here in a way. There's this part of the map, maybe, is my husband's low energy day map. He's not feeling particularly good. He's not going to get pretty far from the house. He's going to stay near home. He still has to walk the dog, so he'll walk the dog, but he's not going all the way to the park. And the other map maybe is bigger, includes both parts. And that would be his high energy map. And that's going to happen with electrons as well. Check it out. Okay guys, almost done. We're getting ready to enjoy our snow day. This is the last little bit. This is the hardest part to understand, so don't worry, we'll go over this again when I see you again. But what I want to show you is that the Bohr model right here, this model of the atom, is arranged in a very particular way so that we can keep track of our electrons. So in the first circle near the nucleus, near this green nucleus, you can see that there are 2 electrons paired together. And those 2 electrons have a probability cloud where they're likely to be found, and that probability cloud is over here in the other model, in the real atom, the quantum atom. And the spot where they're likely to be found, I'll kind of do this in white, I guess, is somewhere inside of that purplish gray looking sphere. And that's because they have low energy, those electrons. They are the lowest energy electrons. That's the first energy shell, the first electron shell. And those electrons are low energy, so it's like my husband can't get far from the house on that day. They can't get far from the nucleus. And then the next two electrons in the Bohr model are found just above the other two. And those two electrons can also hang out in a sphere around the nucleus. It's just a bigger sphere. So it goes all the way from the middle of the atom, all the way from, say, here, from this spot right there, all the way out to this outer circle. And of course, while they're doing that, they're going to try and avoid the other two electrons, the white ones that I drew. So they are likely to be found anywhere in there. So I drew those two electrons as pink. One of them's right in the center, one's near the edge. Now it starts to get weird because all of the space near the nucleus is kind of taken up. So if we get more electrons showing up to this atom, and we do, we have two over here. Those two electrons can't go into one of those two spheres. Instead, they get to go into one of these figure eights. Here's one of the figure eights, this one, which is on the y-axis. This is a place where the next two electrons can comfortably hang out. They're going to avoid the nucleus, so you see how the figure eight gets skinny towards the middle of the nucleus because it's very unlikely that the next two electrons will be found there, because if they're there, they're going to keep running into the pink and the yellow, pink and the white electrons. So these guys tend to spend their time in that figure eight. And the next thing's going to be true for the next pair of electrons. I'm going to change the colors over here to correspond with what I'm drawing. So these guys are actually white, which is really hard to draw on a white background, but you get the idea. And these next two guys are going to be maybe in this figure eight. One guy here and one guy here. And these two guys are going to hang out in this figure eight over here. And then this other guy, him, he's actually got to have a new home, right? And that new home is not shown on this diagram. That new home is actually going to be another circle that's going to sort of overlap all of this stuff. And that electron's going to have to find a home somewhere in there, and it starts to get really, really crowded in this atom, and it starts getting hard for electrons to find spots where they can hang out. But this is the gist of what's happening in electron clouds. Electrons get their own places. You can understand why we don't want to use this model, right? This is much easier. And we'll talk lots more about it when I see you in class, but that's kind of an introduction. See you guys then.